So this was the question. Question was the question is friction coefficient between the two blocks as shown in figure is mu, but the floor is smooth. Floor is smooth. What maximum horizontal force F can be applied without disturbing the equilibrium of the system? Okay, so if you pull this object leftward, then there will be a tension developed here rightward, and the tension will come here also. So this will also be pulled by tension. Okay, so this object getting pulled by tension T in rightward direction, and external force is leftward direction, and this tension will act on this object also, because the tension through the string will go to the lower object as well, and lower object will be pulled rightward. What are the other forces now? There is a friction between these two, and here it is smooth. Okay, on ground it is smooth, and there is a friction in between. So upper object, since it is trying to go leftward, the friction will be rightward, and the lower object, since it is trying to go rightward, the friction will be leftward. So F and F, these are the two frictions. Okay, so first we will, since we have to check for maximum friction, because we have to check the maximum horizontal force. Okay, maximum horizontal force. So maximum condition we will consider. So just when it is about to slide. So the friction maximum value which can act is how much? Mu times normal. And how much will be normal at this surface where friction is acting? The normal here will be equal to mg, small mg, because this normal is balancing the weight of the upper object. Okay, so this is friction. Now if you write the equation, so F leftward minus tension rightward minus friction. Okay, or we can write it. Minus friction equal to, okay, so we have to just balance the forces. So better we can write like this: for small m, for m. Okay, similarly for large m, if we see there is tension and there is a friction. So tension rightward and friction leftward. So these are the two equations. Now you can replace the value of tension. So this is equation 1, this is 2. From 1 and 2, we can replace the value of tension. So we can put small f plus small f. So capital F will be 2 small f, or 2 mu mg. Okay, so this will be the answer for first part. And this is a minimum force which we should apply to move this object. Now second part, suppose the horizontal force applied is double of that part in A, then what will be acceleration? Second part is, this was part A, and part B. Part B, we have to consider acceleration now, means we will not just balance the forces here. So if we consider acceleration, so this one will move rightward with leftward with A, and this one will move rightward with A. Okay, so we can write F minus T minus a small f. Capital F rightward, tension leftward, friction leftward. That will be equal to mass into acceleration. Okay. Now second equation will be, second equation for lower object. For lower object it will be, for small m it is, and for capital M we can write tension minus friction equal to capital M. This is for the lower object. Okay, and since we want to find the acceleration, we can add these two. If you add these two, tension will get cancelled. So F capital F minus 2 small f equal to capital Ma plus small ma. Okay, and capital F is what? Double of that which is found in part A. So how much we have found in part A? 2 mu mg. So double of this. So double of 2 mu mg. It is 4 mu mg minus 2 mu mg a capital M plus a small m. Okay, so A will be equal to 2 mu mg divided by capital M plus a small m. So in this way we can calculate. Okay, so this will be the answer, second part.